What's up everyone? Today I'm doing Fuse from HackTheBox. This box was a Windows machine with a medium difficulty. We start this box off with nmap and we see a virtual host come back in the scan, so we check it out in the web browser and find out it's running papercut. We get some users from the CSV log files that we find on the homepage, and we run the logs through talk to make a password list and we get a hit. Once we update the password, we gain access to rpcclient where we can list a printer, and it results in a password disclosure. We run the password against all the users and we get a match for svc-print, and that completes the user portion. And for privilege escalation, we notice that we can load and unload drivers with the SELoadDriverPrivilege. So we exploit this using Capcom to get a shell as system. So let's get started. We start this box off with nmap svc-coa, put it in the nmap directory and call it fuse, and the IP address is 10.10.10.193. I've already run this, so let's take a look at the output. And we have a whole lot of ports open. We can see RPC, a bunch of Active Directory ports. We have a web server running. And down here, we can see there's the computer name is Fuse. The domain name is fabricorp.local. We have a FQDN, fuse.fabricorp.local. So I'll go ahead and add this to Etsy hosts. Okay, we can go check this out in the web browser. And it's fuse.fabricorp.local. And it forwards us to papercut. So in here we have some logs, it looks like. So we'll go ahead and grab these. Make a directory called papercut. Move everything from our downloads folder that starts with papercut into papercut. Like that. Okay, so in this directory we have 3 logs. Let's go ahead and cat them all. And it looks like we have some time, user, pages, copies, printer, document name. User is interesting to us, and so that's the second field. So we can cat them all, pipe into cut, set the delimiter to be a comma, and we want to grab the second field. And we want to get rid of anything that says HTTP. So we'll invert grep, which is -v, and then we'll sort this and only grab the unique. We'll put this into a file called users, and in users, user was actually the column header, so we don't need that. Okay, so it looks like we got 5 users. Looking at all the information we have, these are the logs. Looks like P. Merton was the owner of this job, and this is a new starter, which is B. Nielsen, so this might be a user we missed, so we'll add this to the user file. And just looking at this, maybe some of these words are important, like Mega Mountain tape request, backup tapes, budget meeting minutes. These are printer names. So what I'm going to do is I'm going to pass this to a tool called Talk, just TOK, which is by tomnomnom. So the way this works is it takes a bunch of input and outputs a list of tokens. So if we just cat everything and pipe through to Talk, it tokenizes it and gives us a whole list of stuff. So if we do that and then we sort it and only grab the uniques, we can see we pretty much have all those words: new, not, notepad, offsite, papercut. And I'm going to put this in a list called possible passwords. So if we look at it, we have all this stuff now. So it's about 89 different items. From here we need a way to test this, so we can just use rpcclient. But let's go and clean up these passwords first. because I don't think any of these 1 or 2 character all of these sizes are going to be a possible password. I think maybe these usernames could be a password. Any of these are probably correct. Anything small like this I don't think is going to be a password. Okay, so this kind of leaves us with 50 things to test, which is still a lot, but it's a lot less. Here we can get rid of com and doctor as well. Okay, so we'll save this. And then, so we just need to write a loop that tests these. So I'm just gonna do a pretty simple rpcclient tester. There's probably a much better way to do this. This is gonna be pretty slow. So we need a loop, and we need a loop through each user. And for each user, we need to test a password. Possible passwords. So for each user, and then for each line, so for each user in the user file, and for each line in the password file, run this command. So we'll just say echo the user without a new line. Say user u, and we'll echo we'll just do user, and then we'll say password p, and then we'll check rpcclient with the username of u and the password of p, and we'll run the command get username, and then we'll quit. And the IP address is 10.10.10.193. I'm sure this has been written before a million times, but I think the first place that I saw this was with one of my teammates, Creep. He kind of wrote this for a quick implementation of how to test rpcclient with throw out the command type thing, and then we just loop through. It doesn't like that bracket though. But I think that's correct. Okay, so let's test this out. I forgot the done here. Okay. So I'm gonna wanna echo a new line after this. And then we'll echo some spacer thing here so we can tell. Right. Okay. So this is going, and we can see that it cannot connect to server. So I'm gonna rerun this, and I'm gonna pipe this to a file called rpclog, and we'll t-a so it writes to it. And we'll just let this run, and we'll come back in a while and see if we get anything other than cannot connect to server. So this has been running for a little while, and I'm just going to check on it. We have the RPC log, so if we cat it, and we get rid of, we grep -v for the user line. And then we grep -v cannot connect to server. And we grep -v for all those dashes. It doesn't like that last one. Do I need to, like, escape these? Interesting. Okay, so we have all those lines, but nothing new. So maybe we just need to look for NT status logon failure and get rid of that match. And see if we have anything here. And we do, we see password must change. So it worked for one of the users, so let's go look in our log and look for the string. And we can see bhult with fabriccorp01, password must change. So I'm gonna put this in my notes. And we can update the password with smbpasswd. So we can just run smbpasswd. And it says new SMB password. If we look at the man page for it, change the user's SMB password. So we can connect to a remote machine with the username and then password, just like rpcclient. So if we look at our notes, we can SMB password our remote machine, which is 10.10.10.193, and the user is bhult, and the password is fabriccorp01. Old SMB password, it didn't like that. Okay, so let's copy this. And I'm gonna paste it, except I'm gonna change the last one to a 2. And it says password is changed. So we can try evil winrm. And our new password. But it doesn't seem to like it. So maybe we have access to something else. rpcclient. The tool that we just ran against. With our new password, rpcclient. And from here, do we have privileges now? Can we look at the users? It looks like we can. So it looks like we have a few more users. So I'm gonna grab these. Add them to the user file. Get rid of all this. And then we can just cut, set the delimiter to be this and the first field. And then we'll sort -u. And now we have all those new users. So cool. From here, we have a bunch of options in rpcclient. You can just tab and see all these options. And the name of the machine is Fuse, so that's kind of a hint. And then also we saw papercut running, so if we look at the printers, so we can just enumerate printers. We see there's an HP printer with a password or scan to docs. So I'll put this in our notes as well. Okay, that was pretty ugly. There we go. And we can do the same thing, except, well, we can do the same thing with rpcclient, except instead of possible passwords, we'll just make a master password list called passwords, and in passwords, we'll put that password and FabricCorp01. Okay, and we'll run RPC again. And we can see the password must change. And I'll just go ahead and let this finish running, and we'll see if there's any different output that we get. Okay, well, it finished running. And we can see that for svc-scan and for svc-print, it was able to authenticate. So these are valid users. So we have one, bhult. I think his name, it was bhult. bhult. So bhult was FabricCorp01. We changed it to FabricCorp02. We have service scan and service print with this password. svc scan and svc print. So let's see if we can connect with evilnrm with these. We need to give it a user, svc scan. Make sure this is on my clipboard. Test this one. Oh, looks like it's timing out. Try it with svc print. And we're on the box as svc print. So heading to the desktop, we can see that we have user.txt, so we can just go ahead and download that. And that's user complete. So we're looking for privilege escalation now. So we can start off with whoami. Look at our groups. So just whoami all, and just look at all the output. And we can see we're a member of print operators. That's a built-in. Looking at the groups, these are all pretty much built-ins. IT accounts does not look like it's a built-in. And our privileges, we have an SELoadDriver privilege, which means we can load and unload device drivers. So loading and unloading drivers is, I think, pretty powerful because drivers usually run a system. So looking for an exploit, we have this great article by Tarlogic. If you want to know exactly what's happening with this exploit, I'd recommend you read this article, but just as an overview, the SELoadDriverPrivilege is available on an account that in this article, that's what it's talking about, but it's disabled, so they enable it, and then they load a vulnerable driver that allows code to be run in kernel space from user space. Essentially, they're loading a known vulnerable driver and then exploiting that. So we can just kind of come down to the proof of concept code, which is EopLoadDriver, and this just allows you to load a driver. So once you compile this, you can just set a service and then the vulnerable driver. So I've already compiled this and I have this here under Capcom. And so we have EopLoadDriver. And a little further down, it talks about exploitation. We can use exploit Capcom, which allows you to obtain a shell as system. So if we read this, it launches a shell as system. So you could go in here and you could modify this code to launch some other code that you wanted. But what we're going to do is we're just going to load the driver. And since it's known vulnerable, we're going to use an msfconsole or a Metasploit module called it's like Capcom.sys. So if we just run msfconsole, gives us a second to boot up, we can go ahead and get the driver part loaded. So if we'll just go into C, make a directory called temp, go into temp, and we'll upload Capcom EopLoadDriver.exe, and that upload EopLoadDriver.exe. Am I in the wrong directory? I might already be in the Capcom directory. Let's just see if we can upload EopLoadDriver. Perfect. Okay, so we can upload that. And then kind of following this article, and even here, it'll say, hey, you just want to run this, name it your service and the driver. So we'll come over here and we'll say we want to run EopLoadDriver.exe, system, current control set, my service is fine, and it's in C temp, Capcom.sys. And that's actually going to fail because we haven't uploaded it. And if you want to get the Capcom driver, I think you can get it from like iRed Team Tools or iRed blog. I forget the name of it. Yeah, iRed.team. I think you can get the driver from somewhere around here. Anyway, it's there if you look. You can find it. And then also in this, it tells you the hash of the Capcom driver you're looking for. So you want to check the hash. So we can check our driver and make sure it's C1DC5 with SHA-1sum. So we can just come down here and SHA-1sum. And we can see we do have the correct file. So we need to upload Capcom.sys. And then we can run our EopLoadDriver. And we get a success. So if we come over here and look, we can see this person gets a success as well. And so now we can run that Metasploit module. So if we just search for Capcom, we can use it. And if we show the options, it says, hey, you need a session. This is our current payload options. So we need to change this. So what I'm going to do is I'm going to create a shell with msfconsole. And the payload we want to use is Windows x64. Interpreter. I think it's reverse TCP RL host is 10.10.14.17. RL port is 1337. Our architecture is x64, and our platform is Windows. And we want that in an exe form, and we'll call it k.exe. So we'll see if this works or if I made a typo. Yeah, I definitely made a typo because I typed msfconsole, and that should be msfvenom. Okay, so we're creating a payload with msfvenom. Seems to work. Okay. So then we can just upload. Oh, in our evil WinRM, we can upload k.exe. And in here, we can use multi-exploit handler, if I spell that correctly. What is it? Is it exploit? It's exploit multi-handler. Ah, there we go. Okay, and then we'll need to set the payload to be what we set in the msfvenom. We'll need to set our L host to our IP address, 10.10.14.17, and set our L port to 1337. Show our options, make sure they all look good. Those look good. Payload looks good. So then we can run multi-handler. Come back over to Ruby, or our evil WinRM, and run k.exe. See if we get a session. We do get a session. And then if we type background, we can say sessions to show our sessions. And we can see we have a 64-bit interpreter session running. And then if we search for Capcom, we can use this again. And we can set session to be 1. And then we can run this. And it says exploit aborted due to failure, not vulnerable. It's not, I'm not sure. I think a reason it's doing this is because if we tried to look at the loaded drivers, driver query from this user, we get an access denied. So if we head back over here and we locate Capcom and we modify this exploit and we get rid of this check that is checking for I'm not sure exactly what this is checking for, to be honest, but let's comment the checks out. And then we can reload the module with reload and then run it again. Okay, so we got exploit finished, but no session was created. So let's look at our options again, make sure everything's correct. Our L host is not correct. Our L host is not the IP address on the VPN. So using this, we need to set our L host, show options. Okay, that looks better. And then we can use Capcom, and then we can try this again. And it looks like it's going to connect back to us now. It sent the payload, opened a new session. From this, we can drop into a shell. And from here, we can see who am I, NT authority system, and the hostname is Fuse. And so from here, we can go into C, users, administrator, desktop, and we can read root.txt. I'm sure a lot of people modified the code for exploit Capcom. I did not. I thought it was really cool that we could just load any driver we wanted, so we loaded a really old vulnerable driver and then used an old exploit that took advantage of that vulnerable driver. Anyways, that's the box. I hope y'all enjoyed it, and I'll catch you guys next week.